Hello everyone, today I want to explain my homework 8 by 1. In this presentation, I will first state the problems, then provide detailed solution and explanation for each one, and finally review the key concepts used in the solutions. The homework consists of 3 problems. All requires us to find the Laplace transform of given functions. These functions involve implements arithmetical and volumetric terms, which will test our understanding of basic transform pairs and properties. Before diving into the solutions, let's recall the fundamental definition of the Laplace transform. It is an integral transform that converts a time domain function into the S domain, which is particularly useful for solving different equations with constant coefficients. To solve 3 problems in physics, we will rely heavily on the first shifting theorem, also known as the frequency shift property, which allows us to handle exponential function multiplied by other functions. We also use several common Laplace transform pairs for trigonometrical and position functions. Let's start with the first problem. The function is 2e 3t sine 4t. This is a classical example for applying the first shifting theorem. We interpret a is 3 and the base function ft is 2 by sine 4t. We first find the Laplace transform of 2 by sine 4t, which is 8 by s multiply s and apply 16, and then shift the frequency by replace s with s to 3 results in the final answer. Moving on the problem 2. T apply 2 multiply 2e and multiply 2t. First, I expanded the square term to get t multiply t, apply 4t and apply 4. This expression is then multiplied by e multiply t, so we again use the first shifting theorem with a is 1. We find the Laplace transform of the formal part, which is the sum of the transforms of t multiply t, 4t and 4, and then shift each term by replacing s with s apply 1. The third problem is e multiply 2t and 3 by sine 4t to 4 by cosine 4t. Using the linearity property of Laplace transformers, we can handle the sine and the cosine terms sparsely. We apply the first shifting theorem to each term with A is 2 using the transform pairs for sine and the cosine. Finally, we combine the two results over a common denominator to get the simplified answer. To simulation, we have successfully solved all three problems. The key takeaway is the importance of the first shifting theorem, which was instrumental in handling the exponential terms in each problem. A solid grasp of basic transform pairs and the linearity property also provide essential for effectively finding the solutions. Thanks for your listening. This is all my homework 8.1. Thanks for listening.